Okay. So echo is basically reflection of sound. Like light can get reflected by a mirror, right? Similarly, sound also can get reflected. For example, say this is the source of the sound, which is a clock, which is ticking. So if you have a pipe like this to make the sound flow through a narrow passage, and if there is a wall, it will reflect the sound. And if I place my ear here, I'll hear the sound here. Okay, so this is a reflection of sound, and this angle will be same. And echo is nothing but reflection of sound. For example, if there's a tall building somewhere far away or a mountain, and there is a person here, and he's clapping his hands, the sound will travel from here to here, and then after that, you'll get reflected, and then reach this person. So this reflected sound is echo. So the time it takes, so first time, see, first the person is clapping, so he'll hear one sound because of that. Second sound will hear because of the reflected sound. The sound is traveling like this, and then it's coming back. So this second time when he hears the clap sound, he's only clapping once. So first, when he's clapping, he'll hear that sound. Second time he'll hear when the sound is getting reflected by the distant object. It can be a wall or a mountain. Okay, so using this time between the two sounds, we can find the distance between the person and the building. For example, the time difference between the two sounds is say 2 seconds. Okay, that means the time taken by the sound to travel from here to here is how much? Half the time, right? It's 1 second. Okay, and speed of sound is known. In air, it's around 330 meter per second. This is the speed of sound speed. Okay, so since the time taken is 1 second, so the time taken is distance by speed. So distance is the one we're trying to find out. And the speed of sound is 330 meter per second, and the time is 2 seconds or 1 second here, because 2 seconds for going and coming back. So the distance now will be 330 meters. Okay. So in other words, if the distance between this person and this building is 330 meters, then the sound will take 1 second to travel from here to the building and 1 more second to return from the building to the person. So in that case, the time interval between the first clapping and the echo hearing is 2 seconds. So if I know the time it takes for the echo to reach me back, I can calculate the distance. So you don't need to measure this distance by using a tape or something. I can also measure this distance by using the time interval between the sound and the echo. So this is one use for the sound reflection. So this is an example. A person claps his hand near a cliff. Cliff is like a mountain. Okay. And the echo is heard after 5 seconds. So what is the distance of the cliff from the person if the speed of sound in air is 346 meter per second? So try to solve this problem. Yeah.
No, sir.
Any doubt?
Illa, sir.
A person claps his hand near the cliff.
The 346 into 3, sir.
Sorry. This is the cliff.
346 into 5 by 2, sir.
Just a minute. So this is the person here. He claps his hand. So the sound travels from here like this and gets reflected and then comes back like this. Okay. So this time interval is 5 seconds because and heard the echo after 5 seconds. So this total time is 5 seconds. So to go from here to the cliff, it is 2.5 seconds. So that time will be equal to the distance between the person and the cliff, that we call it d, divided by the speed. Or in SI units, because time is distance by the speed, right? Or distance is speed into time. So this is the basic relation. Whoever is asking question, you have to speak clearly. Ishwara Vasudev. And if you don't want to ask the question, just mute your mic. Okay. So from this, I can find the distance. Because time is 2.5 seconds. So 2.5 is nothing but 5 by 2 into 346. So 346. Will this go 4 times? 4 8s are 32. So yeah, so 10 by 2 I can write as, sorry, 5 by 2 I can write as 10 by 4 into 346. So 4 will go 8, 32. Oh, it's not going. So 26 will go 6, 46.5. Is that correct? 4 8s are 32, 26, 4 6 are
Sir,
24.
how is 10 by 4, sir?
2.5 seconds, right? 2.5
Yes,
seconds,
sir.
5 by 2.
Into 2.
And 5 by 2 is nothing but 10 by 4. Multiply and divide by 2.
Okay, sir.
That is 10 by 4. And 4 is not dividing exactly. I thought it would. So 4 is 8 times 4 is 32. The remainder is 2. 26. So 4 times 6 is 24. And remainder is 2. And 2 by 4 is 0.5. So this is equal to 865 meters. Let me check the answer.
Correct.
865 meters. The interesting thing is, see, we can measure this distance without using measuring tape or something, right? That'll be a complicated process. And 5 seconds is a good amount of time to sense. It's not a too short of time not to sense. So I'm clapping, I'm hearing the echo at 5 seconds. So using that, I'm able to get the distance of the cliff from the object. So this is a useful way of measuring the distance. Okay. So this is echo. And one more thing is there. Basically, the echo is reflection of sound. Let me finish this last part and then come back. So reverberation means multiple echoes. So instead of having one cliff, I can have a second cliff. Okay. Say cliff 2 1. So sound from here also we can go here and then come back here. So here we'll give 2 echoes. See here there is a source of sound and there is wall here. So one direction sound is going this way, getting reflected and reaching the person here. Second is this one, this one. So all the people in the auditorium are able to hear the sound. What is the direct sound? That will take that is one thing. The other one is this reflected sound. Okay. So suppose this reflected sound is creating a okay, this one way to transmit the sound. Okay, this repeated reflection of the sound. is called reverberation. The auditorium will be called excessive reverberation is highly undesirable. Okay, suppose this echo is creating problem because you will hear one sound directly from the source to the person. The second sound is this echo. But suppose this echo is creating a problem because suppose you're clapping your hands in front of a mountain, hearing it twice, that's fine. But if you're sitting in the auditorium and hearing two sounds, it'll be more like a nuisance, right? So one way is to reduce the amount of sound that's getting reflected. So this reflected sound you can reduce by designing the material properly here. Suppose this material is made of some soft material like cushion or something, then most of the sound which is hitting it will get absorbed. So the amount of sound that's getting reflected will get reduced. So a properly designed auditorium, this reflected sound we can reduce so the sound is heard directly from the source to the person. So this is the design of a good auditorium.
Sir,
So to reduce vibration, the rules and of the auditorium generally covered with sound absorbent materials. So the reflected sound is less, like a compressed fiber board, rough plaster or back, 3PS. Yeah, what is the question?
sir, I have a doubt, sir.
Yeah.
So for a sound wave to reflect, does velocity of the sound wave matter?
No, velocity of sound wave will decide how fast it is coming back.
Yes, sir.
So but the amount of sound that's getting, suppose it's a hard wall like this, then whatever sound energy is going here, 100% will come reflect back.
Okay.
Same
No,
thing.
sir.
Same thing. If the mirror is good, whatever light is coming from the source, all the light will get reflected. But suppose the mirror is not clean, suppose dust is there on the mirror, then the amount of light coming back is less, right?
Yes, sir.
Similarly for sound, the reflecting property of that material, if it's a hard wall, then 100% of the sound will get reflected. But suppose you want to remove this echo, if it's a nuisance, then you make this material something different, like this one fiberboard, so that the
Okay.
most of the sound is getting absorbed by this wall, and only
So
what part is getting reflected.
it does not depend on the velocity of the sound wave.
No, velocity of the sound
Okay.
depends on the medium and also the
Okay.
temperature, pressure, all those things. But the amount of sound that's getting reflected will not depend on the velocity. It will depend, that velocity will decide how fast the sound is coming back.
Yes, sir. Okay, sir.
So reverberation is basically multiple echoes. Repeated reflection that results from persistence of sound is called reverberation. Okay. So, and I can also focus the sound. Suppose this is the reflecting surface, right? And this is the source of sound, like a point source or a speaker here. And suppose there are a lot of people sitting here and you want the sound to get transferred uniformly to all these people here, then I can use a reflector like this. The sound will go like this and go like this. So you get uniform sound for all the people. Okay, so basically I've said echo and reverberation. Reverberation nothing but multiple echoes. And range of hearing, where is the human eye, human ear? This is the human ear. Okay, so inside the human ear, there is a drum like this. Where is the drum? You not mentioned the ear. I think this is a drum, ear drum. Okay, so whatever sound is created, either by a guitar string or a drum or a person talking or clapping or some noise, it will create disturbance in the air molecules, and this air molecule go and hit this eardrum. So the eardrum will start vibrating. Okay, that vibration is sensed by this thing. But this eardrum, it don't pick up sense all the frequencies. So if the frequency is too low, then vibration will not get, the eardrum will not vibrate using because of that sound. And if the frequency is also too high, that frequency or that oscillation of that air will not make this thing vibrate. So this eardrum will have a range of frequencies in which it can vibrate.
Sir, one doubt, sir.
Yeah, just a minute. So that range is 20 hertz to 20,000 hertz. Yeah, what is the doubt?
Sir, so the dog whistle has more frequency, so high frequency, so that we cannot hear it, sir.
Yeah. See, everything has got a capacity, right? Suppose you take a guitar string of a particular length and tension, and if you strike it, it will vibrate only at that particular frequency. Okay.
Yes, sir.
To change that frequency, I have to change some tension or length or something else. Similarly, an object which is receiving the sound, it will have a range in which it can vibrate. Basically, the eardrum has to vibrate. Suppose the guitar is emitting a frequency of some particular frequency. That frequency I'm able to hear because my eardrum is oscillating in response to that frequency, source frequency. Okay. But if that eardrum is not able to pick up frequencies less than 20 hertz, even if we create sound of 15 hertz, the human ear won't be able to hear it. Similarly, the frequency is too, say 30,000 hertz, then the eardrum will not respond to it.
Respond. Sorry. For human ear.
Yeah. So human ear can respond to frequencies only. Yeah.
Sir, isn't human hair concept related portion?
Ask clearly. Speak loudly.
Sir, isn't human hair concept deleted portion?
Okay. Fine. So I'll make it short. So this is the only thing I want to say. Okay. So there are some animals like bats which can produce frequencies which are beyond this range. Okay. So that we cannot. Yeah. What about ultrasound? Is it there? Ultra means the frequency is higher. Okay. So higher frequency waves can get reflected better. So I can use the ultrasound to detect if there is any fracture inside the metal block. Okay. So basically the reflection will occur when there is a change of medium. When there is a fracture here, there is a medium change from this metal. The fracture, there will be a small air molecule, right? Air trap inside it. So there is a change of medium from metal to air. So whenever there is change of medium, there will be a reflection of sound. Okay. Here, the simple thing of reflection using a board, there is also change in medium. Here, because the sound is traveling in air, and after that, the sound is trying to travel in wall. Okay. So there is change of medium, so there is reflection. So whenever there is change in medium, it's possible for the sound to get reflected. So here, it's metal, and this crack is there. So inside the crack, there is air. So there is change of medium, so it will get reflected. So if there is a fracture here, this part of the sound will get reflected here. So this sound will not reach this detector here. So in one side, we are sending the sound, which is the source of sound, and here I'm trying to detect it. Suppose I'm not able to detect the sound in this particular detector, that means that there is some problem in this path. So there is a fracture in this somewhere here. So that way I can detect fracture in this metal block. Like you can find bone fracture using X-rays, right? That's a different process. So similarly, I can find a fracture inside a metal block using the ultrasound, not X-rays, because sound will get reflected when there is a
Sir,
fracture.
I had also.
Yeah.
So, like you said, the range of a human here is 20 hertz to 20,000 hertz. So,
Yeah.
hertz in the sense it's frequency, right, sir?
Yeah, frequency. Yeah.
So, does the human here depend upon the frequency of the sound wave?
Does the human?
No, does the human here, like depend on the frequency of the sound wave or what's up?
Yeah. Basically, the whatever sound is created, you'll have a frequency, right?
Yes, sir. But for a loud sound, we can't expect more frequency, right, sir?
No,
But
no,
how
no.
can we hear it?
Frequency, loudness is different. See, this is some frequency, right? This is low frequency. So this is time. This is also time. Okay, this is amplitude. Okay, so here, this frequency, let me call it 2. So F2, this frequency F1. So F2 is less than F1. Okay, loudness means completely different. This is the same frequency. I can have a second sound like this, say of same frequency, but like this. Okay, so this sound is louder
Okay, sir.
compared to this sound.
Okay, sir.
Frequency, different property.
Okay, sir.
Yeah. So this is a bat which can emit frequencies in the ultrasound range. So it's emitting the frequency. It's hitting the target. Okay. Since there is change of medium from air to this insect medium, it get reflected. So it can detect this. Bats don't have eye, so it cannot see this insect, but it can hear this echo. From this, it can estimate the direction of the. Suppose the fly is here, then the echo will. It has to tilt its head this way to get the proper echo. Okay, so since the echo is coming this way, it will tilt its head in that direction to get the maximum sound. So it can figure out the insect is in this direction, so it will move towards it in that direction. So this is how the bat hunts its food. Ultrasound emitted by the bat and it's reflected back by the prey or an obstacle. And also it will avoid hitting by a wall using the same thing. It will emit the sound. If there is a wall, it will get reflected. So it will know that there is a wall in the front, so it will turn back. Like human can use eye, right, to see there is some obstacle or not. Similarly, the bat can use the sound to see the obstacle or to hear the obstacle. Here, one more thing. Again, here also, like we can find the distance of the cliff by using the sound, right? And the time it will takes for the echo to reach back. Similarly, I can find the depth of the sea. I don't need a scale or something to measure this distance or the depth. I'll emit a sound. It'll go and get reflected back. So using the time interval of this echo, I can estimate this distance, the depth of the sea. And here I have to use the speed of sound in water. Speed of sound in air is 330. Speed of sound in water will be more. Speed of sound in solid is more compared to liquid or gas. Speed of sound at 25 degrees Celsius, it also depends on the temperature. Suppose you fix the temperature at 25. For solid, it's around 6,000, okay, or 4,000 like that. Liquid is dropping down, speed is getting less, and gas is still less. Here it's around 346. One way to understand this is, this gas is like a cushion, right? So speed will not get transferred quickly. It will get slowed down. But solid nodes are rigid. So once you create the sound, the distance just travel quickly.
So,
Yeah.
so what is that hydrogen, helium? So they are also particles in the air, right? So
No, hydrogen, not particle. H2 will form a gas, no? Hydrogen atom, both will join together to form hydrogen gas.
yes, sir, but still it is a particle. It is still in the form of air, right, sir? It's a gas.
Yeah, it's in form of a gas, H2 molecules.
Okay, sir.
So if you have two hydrogen atoms, they join together. Three hydrogen atoms won't join together. Two hydrogen atoms will form a molecule. If you bring the third hydrogen atom, you'll wait for another one to come. Fourth hydrogen atom to come to form another molecule, second molecule. Okay. Similarly, oxygen also will have O2, right? So two oxygen atoms will combine to give one molecule. If there is a third oxygen atom, it will wait for the fourth oxygen atom to come. Okay. Sulfur dioxide is SO2. So one sulfur atom and two oxygen atoms, they will form a group. Okay. So basically gaseous state. The difference between solid and liquid is, in solid, the atoms will not move. But in liquid, atoms can move, and the shape is also not rigid, right? But gas, the atoms or molecules can move, and also the distance between the molecules can change. Here, water, the distance between two water molecules is same, it will not change. But hydrogen molecules, they can move far away. There's nothing that's binding them. So if you take 100 ml of hydrogen and put it in a small bottle and convert it to a bigger bottle, it will occupy the full bottle. In that case, in the second case, the distance between two hydrogen molecules is increased. But if you take 100 ml of water and put it in a 1,000-liter tank, it will still remain in the corner. It will not occupy the full volume. Because that's because the distance between two water molecules will not change. just because I changed the container. That is the difference between liquid and gas. Okay. Solid I cannot move, or it will be a rigid thing, right? It will not take the shape of the container. It's rigid compared to liquid. But in this chapter, we are studying the sound property. The sound property will be speed of sound will be more in the solid compared to gas and liquids in between. So with this, this chapter is over. So all the chapters are over for your physics course. So I think you will have a final exam after Pongal, and after that, 10th standard portion will start. So this is the one here again. It's same time, right? So this higher frequency, this lower frequency. Okay, here the frequency is same. If I compare these two, frequency is almost same because time interval is same. But this is a amplitude is less. Here the amplitude is more. So this is a louder noise. This soft noise or lower noise, low sound. This frequency and amplitude are different properties. Frequency is also called pitch. Pitch is same as frequency. So this is low pitch, this is high pitch. And frequency is 1 by the time period. Here the time period is moved. The time period is from here to here. Here the time period is from here to here. So time period is short here. So frequency is 1 by time period. So this is a higher frequency. Yeah, the important thing about sound, it's a wave, it's function of both space and time. Here they have put the sound wave as a function of time, sorry, function of space, which is distance. And here they are shown as a function of time. Okay, so time will have a periodicity, and the reciprocal of the time periodicity is a frequency. Similarly, the space variation of sound or distance, that also has got a periodicity, and that periodicity is called wavelength. So your wave will have two periodicities. One is the periodicity with respect to space, which is the wavelength. Another periodicity with respect to time, that is the frequency. Or the reciprocal of the time period is the frequency. So is that clear? So to put in another way, sound is function of both space and time. Okay. So you can plot as a variation of space, that will give me wavelength, the periodicity. Similarly, if you plot as a function of time, that periodicity will give me time period, and the reciprocal of that will give me frequency. And the frequency and the wavelength are related as speed equal to frequency to lambda. That's one important relation, right? Speed is distance by time. In one wavelength, the distance traveled is lambda, and the corresponding time is the time period. So from this, I get the and 1 by t is the frequency. Here they put as nu. So speed equal to nu into lambda. This is a basic relation, an important relation. So this wavelength is the time periodicity, and this frequency is the wavelength is space periodicity, and this frequency is the time periodicity or the reciprocal of time periodicity. So both the periodicities are related by the speed. Okay. And frequency is 1 by time. So the unit of frequency will be 1 by second, that is per second, and that is called hertz. Hertz is nothing but second raised to the power -1.
Sir, what is sonar, sir?
What is
Sonar.
sonar? Sonar is basically it's like radar, no? In radar, you use the electromagnetic wave In sonar, you use the sound wave. Sonar means ultrasound. Just one, where is sonar? Basically, you can find the direction of the object. Navigation and ranging. Suppose there is a airplane coming on the sky. I can detect the direction of the location of the plane using radar. That's using electromagnetic waves. Okay. Similarly, I can also use sonar to find the direction. But here, sonar is basically used in here. This one, here there is a source of sound, right? It's being reflected by the seabed and coming back. So this is sonar. Sonar is basically emitting ultrasound. Ultrasonic waves, it's ultrasound means ultra means high. Okay. So ultrasonic means high frequency. It will be beyond 20,000 hertz. So from this I can find the this one. Depth of this thing. Similarly, I can find the cracks, no? Suppose there's a metal here and there's a crack inside or fracture inside. I can find there is fracture. So this also, okay, sonar is basically in that particular application. This particular application is called sonar. Then I'm finding the depth of the sea. Or I can say sonar is basically a reflection of sound, where the sound sources are ultra frequency or ultrasound. Sonar is on submarine sensor signal. Basically, using ship. So like X-ray, which is used to see the bone structure inside human body, I can also use ultrasound to get the details of the inside of the human body. You can see kidneys, whatever you want to see. Okay. The advantage of ultrasound is it doesn't create harm to the human body. Except taking too many X-rays or too often X-rays will create some damage to the human body. But ultrasound is harmless, relatively. So that is advantage of ultrasound. Any other question? Sonar technique used to determine the depth of sea and to locate under water hills, valleys, submarines, etc. It's like ultrasonic is the frequency
So
high.
sonar is under the application of reflection of sound rays, sir.
Sorry?
Sonar, it is coming under the application of reflection of sound, isn't
Yeah.
it? Okay, sir.
Basically finding the depth of the sea, right? And also if there's any obstacle inside the sea, like iceberg or something, we can detect.
Okay, sir.
Like ultrasound means frequency is higher. Similarly, I can have infrasound where the frequency is less, say less than 20 hertz. That's called infrasonic. Okay. Ultrasound means frequency is high, infra means frequency is low. So it's lower than the audible range of 20 hertz. So any other question? So basically we had how many chapters? Motion, laws of motion. What is the third one? Electricity? No.
Gravitation,
Gravitation. After
work
that,
and energy, and sound, sir.
work and energy and sound. Okay. Right. So 5 chapters for you. So get ready for the final exam.
Are all 5 chapters coming for the second term, sir?
Sorry.
Are all 5 chapters coming for the final exams?
Of course. Annual exam, right?
So no, sir. Only work and energy and sound.
Is it?
And gravity.
Ma'am said.
Okay, I'm not sure.
Yes, sir, ma'am said.
No, that is term 2 or final exam?
Sir, term 2 and the final exam is the same, sir. Ma'am said so.
Mufida ma'am. And,
Yes, sir.
and it will be after Pongal, right?
No idea, sir.
Sir, they didn't even complete the Unit 6 examination still.
Didn't even complete what?
It's last unit exam, sir.
Okay.
After that only most probably the final exam will take place.
Yeah. Okay. Okay, we'll close in a minute. If you have any So next class, maybe I'll solve some problems from the lead book.
Okay, sir.
Okay.
Okay. So shall we close now?
Yes, sir.
Yes, sir. Yes, sir.
Okay, thank you.
Yes, sir.
Sir,
Thank you,
sir,
sir.
Thank you,
Yeah,
sir.
tell me.
sir, for the sir, I think
Thank you, sir.
probably we'll be having question banks for the unit assessment, right, sir?
Yeah, I'll give.
Yes, sir. For in those question banks, would you create your own questions, or
Thank you,
would
sir.
it be coming from the lead or NCRT, sir?
No, question bank is created by me.
Okay,
Okay,
sir.
but the final exam will have part from the question bank and part from the lead. It will be a mixture,
Okay, sir.
not
Okay,
fully
sir.
question bank.
Okay,
Like
sir.
last time.
Okay, sir. Okay, sir. Thank you, sir.
Thank you, sir.
Yeah, fine. Bye.
Thank you.
Bye, sir.
Yeah.